Hey ladies and gentlemen, today we will talk about lesson 4, numerical integration. The objective: after studying this lesson, you should be able to use the trapezoidal rules and the Simpson's rules to evaluate integrals. First, I will talk about numerical integration. To find the value of definite integrals fx from point A to B, we first have to find fx dx, but this is not always possible. For example, fx equals to x to the power of 4 over sine x to the power of 3 plus tangent x to the power of 3. This cannot be done, so we have to find another way to solve this equation. The definite integrals fx from point A to B represents the area between the curve y equals fx and the x-axis from x equals A to x equals B. So even if fx dx cannot be found, an approximate value for fx from point A to B can be obtained by evaluating the appropriate areas. We will now look at two methods for finding the approximate value of the area bounded partly by the curve and the x-axis. One of the methods is trapezoidal rules. As you can see from this graph, if the area represented by fx from point A to B is divided into n straps, which is each of the width h equals b minus a over n, as shown above, then each strap is approximately a trapezium. The area of a trapezium is half sum of parallel sides times distance between them, which is equal to half distance A plus B times the distance between them h. Using the sum of the areas of the stripes as an approximation for the actual value of the area we have. Now we'll look at how to solve this equation. Fx from distance A to B equals to half y0 plus y1. The y0 is equals to this value, and the y1 is equals to this value. So we can know that this is a trapezium. Okay, so we will add on to the number of straps we use to the n terms. Example: fx from distance A to B equals to h over 2 bracket x0 plus xn plus 2 over bracket x1 plus x2 and so on and so forth. Now I'll have an example. Evaluate this equation by using trapezoidal rules with 4 stripes. Let fx equals to square root of 1 minus x cubed. N equals to 4. Then the length of each sub-intervals is h equals 1 minus 0 over 4, which is 1 quarter, and it is 0.25. This is obtained to get the value of x between point 0 to 1. Now with this value, we will sub in into the equation fx to obtain the rest of the value, 0.9922 and so on and so forth. By trapezoidal rules, this equation equals to h over 2 y0 plus y4 plus 2, which y1 plus y2 plus y3. We sub in all the values we obtained from just now into this formula, and thus we will get the answer 0.79. And now I will talk about the advantages and the disadvantages of